Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, episode 17 of 17. You would never deploy back-end application code without unit tests, so why are data pipelines often pushed to production on a wing and a prayer? Snowpark changes this by making your data logic modular, meaning you can finally test it like normal software. Testing Snowpark Python is what brings software engineering rigor to data engineering. Snowpark allows you to pull your transformation logic out of monolithic scripts and into standalone Python functions. Because these functions take a data frame as input and return a data frame as output, you can test them using standard Python frameworks. PyTest is the most common choice. To run any Snowpark code, you need an active session. Instead of embedding authentication details inside every single test, you define a session fixture. You do this in a dedicated configuration file called confest.py, which PyTest automatically recognizes. Inside this file, you write a setup function that establishes a connection to Snowflake, returns the session object, and closes the session when the tests finish. You decorate this function as a PyTest fixture. Now, any test in your project can request an active session simply by asking for it by name in the test function arguments. Let us apply this to a concrete scenario. You have a complex custom data frame transformation that filters out inactive users, calculates a risk score, and standardizes column names. You need to validate this logic before deploying the pipeline to production. You start by writing a test. The first step inside that test is creating an input data frame containing a few rows of carefully selected mock data. You define the exact column names and row values needed to trigger the specific edge cases in your logic. You use your session fixture to convert this raw mock data into a Snowpark data frame. Next, you pass this mock input data frame into your transformation function. The function applies your business logic and returns the actual output data frame. Now you need to verify that the logic did what it was supposed to do. You create a second mock data frame within your test, this time representing the exact expected result. This is the part that matters. You must compare the actual data frame against the expected data frame. However, you cannot just use standard Python equality check on the data frames themselves because they are merely references to query plans. Instead, you need to compare the data they contain. You call the collect method on both the actual and expected data frames to pull the results back into memory as lists of row objects. Because distributed databases do not guarantee the order of result sets unless explicitly instructed, comparing two lists of rows directly might fail even if the data is correct. To fix this, you sort both lists of rows before asserting that they are equal. If the sorted actual data matches the sorted expected data, your test passes. By passing small, controlled datasets through isolated transformation functions, you catch logical errors locally before they ever touch a production table. This isolates your pipeline components and makes your data engineering workflow as reliable as traditional software development. This marks the end of our series on Snowpark Python. I encourage you to explore the official Snowflake documentation, try writing these tests hands-on, or visit devstories.eu to suggest topics for our future series. I would like to take a moment to thank you for listening. It helps us a lot. Have a great one.